Hello, in this video I want to briefly explain what you are going to do in the exercises this week. These exercises are supposed to get you to think about the derivations from combinatorics that we've just gone through in the videos and quizzes in more detail. To complete these exercises, you are going to have to learn about a new data type in Python, namely a list. I could have introduced lists in previous weeks, because we have used NumPy arrays to do everything that we might have done with a list. As an example of the sorts of things that we could do with a list that we have previously done with NumPy arrays, consider this code here. As you know, this code creates a NumPy array with 10 elements, and then it sets each of these elements equal to the first 10 non-negative integers. If I'd written this same code with lists instead of NumPy arrays, I would have written something like this. This code creates an empty list and then adds or appends to the end of the list each of the first 10 non-negative integers. A perhaps irritating feature of Python is that there are multiple different ways to achieve the same result, as is illustrated on this slide. In other words, there is not one single right way to achieve a particular result. Furthermore, as you will learn when you get a bit further along with Python programming, there are often subtle advantages and disadvantages between these different ways of doing the same thing. For example, the second code on this slide will take longer to execute than the first code on the slide. Let's consider these two codes one further time in order to better understand the differences between these two ways of achieving the same result. As you know, the first command in the first code creates a NumPy array with 10 elements. All 10 elements in this list are set initially equal to 0, as is illustrated here. As we work through the loops 10 times, these elements are then reset to the appropriate values, as is illustrated here. If we now look at the second code by contrast, the first line creates an empty list, as shown here. The loop then adds progressively more and more elements to the list, as is illustrated here. In other words, because we are using the append command here, which does not exist for NumPy arrays, the length of the list increases by 1 on each pass through the loop. There is another important difference between lists and NumPy arrays. A NumPy array can only contain numbers. A list, by contrast, contains data of any type. We can thus have a list of numbers, a list of characters, a list of NumPy arrays, or even a list of lists. You're going to use the fact that lists can store lists in their elements in the exercises that follow. In particular, you're going to write programs something like this one. The first line of Python code here creates an empty list called allComs. This line then appends a list containing the numbers 1, 2, and 3 in that order to the empty list called allComs. This action is repeated 6 times, although the order of the 3 symbols, the 1, 2, and 3, is different each time. The net result is that once the code is complete, allComs contains all 3 factorial permutations of the 3 symbols 1, 2, and 3 that it is possible to form. In the exercises that follow, you will thus write a function to generate all the possible permutations of n symbols. Writing this program will hopefully help you to better understand the proofs that were explained in the videos at the start of this section. Good luck with those exercises, and thank you for your attention.